Hello and welcome to the 25th Vermont Grazing and Livestock Conference. I would like to take a moment to thank our sponsors. I would like to thank the National Grazing Lands Coalition, Food Animal Concerns Trust, Morrison's Custom Feeds, Rural Vermont, and the Vermont Agency of Agriculture, Food and Markets. I would also like to thank our partners. I would like to thank the United States Department of Agriculture, National Institute of Food and Agriculture, and the National Resources Conservation Service. I would also like to thank Cedar Tree Foundation and the Forrest C. and Francis H. Latner Foundation. Thank you for joining us for the 25th Grazing and Livestock Conference. The conference is brought to you by the University of Vermont Extension Center for Sustainable Agriculture and the Vermont Grass Farmers Association. Enjoy the content.
Hello, everyone. So I'm going to give a quick introduction to Juan this morning. My name is Sam Corcoran. I'll be his moderator as well as your question asking liaison this morning. Dr. Juan Alves comes from a 2-generation pasture-based farm in Uruguay. He has a bachelor's in agronomy with a focus on agroforestry and pasture management. He has a master's in plant and soil sciences, and he has a PhD in natural resources from UVM. So suffice it to say, he is very qualified. Juan joined UVM in 2012, where he works in the Center for Sustainable Agriculture. There he does applied interdisciplinary research in soil health and grazing management. Juan's work addresses environmental and productive aspects of grazing farms with an emphasis on grazing management, ecosystem functions, and sustainable livelihoods. He views grazing lands as complex ecosystems that have the ability to support healthy environments and communities. And his interests include ecosystem services, conservation policy, green markets, and ecological economics. So before I turn it over, just so everyone listening in knows, during the presentation, I will interrupt for any critical clarification questions, but otherwise we will try to hold most questions until the end. We do also have a hard stop time today of 11:15, so we can allow the next session to open up. So at about 11:05, we will stop and open up for a 10-minute Q&A session. And just one more reminder to submit your questions, please, in the Whova Q&A box. And you can also be submitting your chats in there as well. So with that, Juan, I'll let you take it away. Your mic is on mute still.
Okay. Share screen number 1. Okay. Can you hear me, Sam?
Yes, we can hear you.
Okay. Thank you so much, Samantha, and Vermont Grass Farmers Association for this new edition of the 25th Vermont Grazing Conference. Wow, amazing. Thank you so much for being here today. I will, first of all, I never assume that everybody is on board with all the topics on grazing management. So I will assume that there are people that may not be familiar. So I will talk about the basics. I will talk about the four main principles that guide pasture management. I will talk a little bit about soils. I will talk a little bit about finishing, how to build a finishing program with your animals. So I'll start jumping right on. I assume that most of you are grass farmers or intend to be livestock grass farmers. And I think you need to know that if you are a grass farmer, you are on the right track, because choosing forage pastures to start a grazing operation is the least expensive type of feed, while it offers same or superior quality as any other feed. And I want you to know that, the older your pasture gets, the better it gets. Okay, so the older your pasture gets, it will develop more pores, which will give access to oxygen and water. And this is more assets for building more microbes and more infrastructure around the soil, which will give better pastures and better animals. Let's keep going. So when you build a pasture operation, you need to know the principles. You need to know the grazing arithmetic. You need to basically think about a pasture subdivision. Always think about, having maps of soils, maps of, topography, or areas of your farm that you may need to know some of the details. You need to bring water to your animals. So water always follows animals, because once I was studying agronomy, I learned that, and this is going to go in metrics, but for every meter, and 1 meter is 3 feet, for every meter that a cow walks, it spends 1 calorie per kilo of live weight. Okay, for every meter that a cow walks, it spends a calorie per kilo of live weight. So that doesn't mean that cows should not walk. They need to walk. They need exercise, and they need to be outside as much as possible. But water should follow the animals, or should be in every pasture. Okay. Also, you need laneways. You need to provide shade or shelter for when temperature and weather conditions are really difficult for the animals to bear, especially in the wintertime, especially when it's wet and windy. Okay. And in the summertime, anytime is above 80 degrees, it's good to have some living barn with trees, a pasture where you have trees that animals can shelter for a little bit until the most of the heat passes. Okay, so you need to build your forages and your feed planning with hay and silage. And you need to bear in mind that you will manage animals in high stock density, rotating them through different pastures. You need to keep records, and you need several calendars to put together your operation. And now I'm going to talk about some of the principles that that guide pasture management. This is not a forgotten man, but almost nobody talks about him. This is Marcel Voisin. He was born in France, in deep France, in 1903. And he died in 1964 in La Habana, Cuba. He was a researcher, a biochemist, an author of several books. And he had a farm, about 25-acre farm in Normandy. His farm was called L'Etalou. And he set out he calls 4 laws of grazing. Okay. And I'm sure most of you have heard them, but I will go through these because I'm sure there's some people that have not heard them. Okay. And we're going to develop each of these laws. Okay. And talk about them. Okay. So the first law is the law of rest or recovery. And it says, for a grass to achieve its maximum productivity, it must be given enough time to recover between grazing intervals. Okay, so this rest period is essential to give forage time to build adequate root reserves capable of sustaining vigorous growth. Okay. And this rest is influenced by the season of the year, by the climate conditions, by soil fertility, and other environmental factors. Okay, so again, I think I saw this chart yesterday by Rick, I think, but this portrays. This is a chart that I put several other charts on top of it and more information on top of it. So on the vertical axis, you have total pasture and dry matters in pounds per acre. And on the horizontal axis, you have regrowth over time. And you have a curve for the pastures and a curve for the roots. So when you, if you can see my pointer here, when you when you have a pasture, when you graze a pasture, the pasture depletes when you graze a pasture down, the pasture depletes most of these non-structural carbohydrates, which are the sugars or the starches that provide the plant with provide the plant with the energy for the plant to regrow again. And then the plant goes into a spurt of growth, which is called, which Voisin calls the blaze of growth, because it grows very fast until it reaches phase 4. So as it grows, as the plant is young and is growing, it has high protein, total digested nutrients, high energy, high palatability, and digestibility. And as it grows, this quality starts going down, because all these components give access to lignin and more cellulose, and those are fiber. Those are components of fiber. So there's a time when you can graze this pasture, and when it reaches a certain point, and this point we will talk in the next slides. And as it grows, it builds non-structural carbohydrates in the root system, so that it's ready to provide its energy again. I'm sorry about the blurriness of this slide.
Juan,
But
could I actually interrupt you? Sorry, just for
Yep.
one moment. You're actually you're in presenter mode. So people see your screen as the presenter mode. Would it
Okay.
would it be easy for you to change your display settings?
Let's see.
If you just go back to slideshow and from current slide.
Are you seeing my screen right now?
Yep, I see your screen.
Okay.
If you click on slideshow again.
Slideshow.
And then if you go to display settings.
Display settings.
Yep.
Okay.
And it's swap. I think that should. There you go.
Okay.
All set.
Good. Sorry. Okay, this works. Yeah. So so this is sort of the same slide, but from the plant point of view. Okay, so you have a young plant that's being grazed, and it's growing and it's leafy, but it shows the stages of growth. So basically, this divided in 4 stages of growth: leafy, bud, heading, and bloom. And you want to maximize forage intake, but you want to minimize the damage that too much fiber can pose on your animals. So in one word, there is an optimal time to graze, right? Oh, so sorry. All right. Let's swap again. So that the primary factor influencing the nutrient value of forages is the maturity at the time of harvest, right? So the ideal time for harvest is between vegetative and bud, because then you maximize yield and quality, right? So you need to know the stages of growth of your pastures for a successful grazing management. And you would like to have pastures that have mostly these numbers here for each stage of growth. You know, on a pre-head or early head around boot, you want a little less energy. You want a little less crude protein and less fiber for grasses and for legumes, because the maximum yield of dry matter, because you have to graze between the maximum yield of dry matter and the maximum yield of digestible dry matter, and that corresponds to boot, stage, or early heading. We'll see pictures of that. So this is a typical cool season pasture in the Northeast. Red clover, orchard grass, Kentucky blue, fescue, and maybe brome. Okay. You want to look for signs of early budding, where you see a little bit of seed heads, but appearing, but not too many. And the ideal residence period of occupation for this pasture is 12 hours, but you can occupy this pasture for less time or for more time, but no more than 3 days. You have to be mindful of overgrown pastures because of what I said about the amount of fiber and the least amount of desirable features in your feed. So when to graze, when the root system. So we can think about when to graze from a theoretical point of view, and we can say, well, when the root system is completely replenished, or when forages reach about 95% of light capture, or when pasture growth acceleration sigmoid curve equals 0, or when non-structural carbohydrates reach about 20 to 30%. But what does it mean practically? So choose paddocks according to the optimal rest period. Okay. Or when grasses start bending over their own weight, or when they are in early boot, or first seed head appearance start show up, or when legume flowers do not exceed 30% in diverse pastures. Okay. And why grazing in the optimal graze period is important is because this is when you have the maximum amount of dry matter in your pastures. All right. And here's a picture that many of you know already, I'm pretty sure, where it shows the consequences of grazing continuously, or doing extensive grazing, versus grazing more regeneratively, where you allow plants to grow until their optimal rest period and then graze them. Because when you allow them to grow to the optimum graze period, you start developing the root system, and the root system is what develops soils. So we make soils with grass or with forages, because these forages start exudating those carbohydrates, those sugars, into the soil in exchange for minerals. And they start building this infrastructure underneath that will be beneficial to your forages and to your animals. So enough, you have to have enough diversity of plants so that you can build a resilient system, so that if one plant is attacked by a pathogen, you have several other plants. But also because plants grow at different periods, and they can fill out niches, or they can produce different root infrastructure underneath, which will be beneficial to your soil as well. The second law of grazing is the law of occupation. So this law says the time animals spend in a paddock should be so short that they do not regraze the same grass for the second time before they move to the next paddock. So if this happens, if they regraze the same grass for the second time before they are moved to the next paddock, we call it overgrazing. So for this not to happen, occupation should be minimum, and the ideal occupation should be also what is flexible to the farmer or to the livestock manager. But the ideal to me is how dairy farmers do. They change animals every half a day because they milk twice a day. So every time cows return to pasture, they return to a new fresh pasture. But do not use your do not occupy a pasture more than 3 days, and we will see that. Well, we will see why. So some common circumstances that will cause overgrazing damage is having a fixed rotational grazing system of few paddocks and grazing each one for more than 1 day, grazing for more than 3 days, more than 7 days each one. These will not work in the long run. Another point is returning animals to a pasture too soon before plants have regrown, or taking down interior fences and letting cows clean up the pastures, in the fall. It's a practice that some people do. Also, not adding additional acres or subdivisions into the summer rotation when plant growth rates slow, because that will cause overgrazing, and you will end up with a continuous grazing rotational system. So number of subdivisions is like love. The more, the better. Okay, but of course there is a what is it called? An economic problem, so, and also labor problem, the more subdivisions. So you have to do the grazing math and see how many paddocks do you need for your farm at a given time. How to move animals and when to move them. And I want to emphasize this because in the United States, most of the grazing systems I've seen are sequential. And the right way, if we are going to respect the first law of grazing, the law of recovery, you have to move to your pasture, to your next pasture, when, and I'm so sorry about my puppy, but we're quarantining at home. So you have to move to your next pasture when, according to your optimal rest period. So when your pastures are ready. So that doesn't mean that means that you have to move non-sequentially, because if you move sequentially, you might be compromising pastures in other areas. If you're lucky to have machinery to harvest the areas that are ready, great. But usually you should move your animals where your pastures are ready in your farm. And for that, you need to walk and observe your pastures. So well-managed pastures, in well-managed pastures, paddocks are not grazed in the same order that they stand. What you want to produce is like a chess effect in your farm if you look at it from above. Does that mean that strip grazing is not allowed? Absolutely not. So you can use strip grazing if it fits your model. You have to be flexible, but bear in mind that the right way to do it is to move your animals where the pasture is ready to graze. So in the picture below, you can see the chess effect on a very small farm versus the sequential grazing, which is moving your animals, putting a front fence and sometimes a back fence. The third law of maximum yields, help the animals with the highest nutritional requirements to harvest the most quantity of best quality forage possible. Okay, so you have different types of animals, and they have different requirement needs. And the ones that require more and better should graze the best and the most. Simple as that. And this is a chart. I don't want to go through this chart, but it's a chart, lactation by month for cows. And it shows when is the peak dry matter intake and peak milk of the cow. So you should time or adjust your animals to your pastures. A little word about stock density. It allows for higher harvest efficiency of the forages. It distributes manure in a much better way when you have enough animals. It builds soil fertility over time. It produces higher pasture productivity. It increases carrying capacity of the system as a whole, and return higher economic results. But also it promotes the voracity of the animals to eat and not get distracted. If you have low stock density, a few animals to the acre, or a few animals to the paddock, in each given time, that voracity won't express itself. So you're going to end up with uneven pastures. When you have high stock density, you will have even pastures, and as Sarah mentioned today, you'll have much better control of your weeds. So when forage is too tall or too short, it produces an inefficient bite size. So if we meet the 4 laws and conditions are ideal, bite size and weight can maximize intake. Okay, because we know roughly that a cow takes about 30,000 plus bites a day, an adult cow, and we want to maximize intake as much as possible. So presenting this cow with the right forage stand, it's very important. Feed intake. So different feeds have different dry matter and percentages, and you have to count feed as a dry matter basis always. Okay. Here there's a relationship between weight gain and methane production per kilo of gain. So the more you gain per day, or the more you gain per day, the least methane these animals will release. So another argument to in favor of presenting these animals with an adequate pasture. Forage diversity. Diversity is very important to overcome problems with bloating. So there are few forages that can help in that end, and burst fruit trefoil are high in tannins and can help. Burst fruit trefoil and veg can help minimize bloating in animals. The fourth law of grazing is the regular yields law. If a cow is expected to produce milk and consistent weight gains, it should not spend more than 3 days grazing in the same paddock. Milk production and weight gains will be maximized if cattle spend no more than 1 day in each paddock. Okay, this is what Juan calls a law, and is the fourth and last law. Okay, and this is a typical forage quality that you should present your pasture, your animals. High dry matter, relatively adequate protein, low fiber, and high energy. And Rick went through these yesterday, so I'm not going to go through these. So I go back to this slide because I want to show, what happens when you put your animals more than one day in the same pasture. And I'd like to borrow from Jen Colby this description that, the first day, so this is grazing days. So the first day they are in the dining room. The second day they are in the bedroom. And the third day, and from the third day on, they will be in the bathroom. And intake will dramatically reduce. And also quality and weight gain will dramatically reduce. So let's jump into the grazing math. So every day your animals graze, you save money. Because as I showed in the first slide, pasture is a least expensive feed with the same comparable quality. Dry matter demand needs to match with dry matter supply. And different animals and different categories of animals have different dry matter demands. So lactating cows have like 3%, but sheep and goats have about 3.5. Beef and dairy heifers have between 2.5 and 3% of their live weight. So I'll quickly go through a little exercise that, if you have 20 cows and they need to eat 30 pounds of dry matter per day, you need about 600 pounds per day to supply to these 20 cows. Okay, and this is what I just said. First, determine the animal consumption in dry matter per day, and then determine the daily herd consumption. Then you have animal units. Determine how much forage is available. Estimate pre-grazing yield. Okay, in this example, we have about 2,500 pounds of dry matter. You want to graze this down. If you graze this down to 2 inches, which could be low, and bring it down to 1,200 pounds, you will have dry matter available of 1,300 pounds available to these animals. To calculate your daily strip or paddock area, you need to divide dry matter demand by dry matter available by supply. And then your paddock size will be equal to 600 pounds of dry matter per acre divided by 1,300 pounds of dry matter available, which would be about roughly half an acre. Okay. I'm going to speed up a little bit. So in this second exercise, this 500 kilo Holstein dairy cows need about 750 kilos of dry matter per day. You apply the same formula and you end up with about 0.75 hectares per day. And I use I'm using metric here because it's easy to me. And I will reuse this slide that shows that 0.75 hectares per day means 75 meters by 100 meter strip. This is what these animals need on this day, on each given day. So I'll jump into other tips. Problems with continuous grazing. Continuous grazing will cause a lot of compaction, very low infiltration, very low production forage. It will lower your carrying capacity of the whole farm in in the long run. It will increase the amount of parasites. It will lower production overall, and is not sustainable over time. On the other hand, you have tall grazing, which has really important benefits for soil health. And high stock density reduces cow selectivity by encourage what I just called in a previous slide voracious grazing. Animals are going to compete against each other, and they will be really grazing down everything and trampling a lot of and it's this system versus continuous grazing produces a lot of results per area. Some of the cons of this method is that you lower the energy in these forages, you lower you increase the amount of fiber, and you lower the total digestive nutrients in these pastures. But with this voracious eating, you have a great and even manure distribution across the pasture, which over time will produce this beautiful feature that I love to see, those ghost bumps, and mostly produced by urine patches. So merging a little bit the conversation into soils, the cow is a perfect soil generator, and it collects and shreds huge amounts of organic matter, inoculates it with beneficial bacteria in the rumen, and filters rocks, and generates single units of antiseptic, seedless, perfect units of soil. I want to give a little bit of tips here that cows in high stock density return 90 to 95% of nutrients. So graze the hay fields if you want to provide them with more nutrients. If animals have to walk 1,000 to 2,000 feet to drink water, manure and urine will not be evenly distributed across the pasture. So think that water should go to the animals and not the other way around. And an adult cow produces, upwards of 271 pounds of nitrogen, 100 pounds of phosphorus and calcium per year, and around 117 pounds of potassium per year. So they did an experiment in Uruguay about 700-pound steer, which they measure. It produces about 50 pounds a day of manure, and they were able to track how much nitrogen, phosphorus, and potassium it returned to the field, and how much was that in fertilization. So this steer is adding $90 of fertilization per year. Another example, maybe not bring this example. I don't bring this example, but this is a farm in Brazil that started doing rotational grazing in 1959, and they measure organic matter, phosphorus, and potassium. And in 1993, they never applied any fertilizer. The changes were like almost 8 times for organic matter. Organic matter was very low. It was a sandy soil. 16 times for phosphorus, and about 33 times for potassium. Never applied any fertilizers. The organic matter is the most important soil quality indicator. And this is important because usually fertilizer prices follow food prices, so it's a really important to have in mind. And it's also important because we need to build soil, because we're losing soil dramatically, and we are growing as a population, and there's less and less area per person. So if you want to build a finishing program, you need to use any practice that has into account to increase the amount of dry matter per acre and its digestibility. So bear in mind the 4 laws of grazing. When we increase quantity and quality, we also increase protein and digestibility, which increases intake and production as a whole. So think about, this is not set in stone. These numbers are not set in stone, but my ideal dream would be to have a production of 10 to 12,000 pounds of dry matter to the acre with 80% utilization. Convert 25 pounds of dry matter into 1 pound of beef, and to make as much money as possible per acre. And how do you build a successful finishing program? You had to build a sequence of forages, adding summer annuals to cope with the summer slump. And when strip grazing, you always should use a back fence so these animals don't walk on the pastures again. I'm mindful of my time. So most of the common cool season pastures in the Northeast are these ones, and below is a chart with the distribution of when they grow. So you need to be able to cope with the summer slump by adding annuals and know which species will give you the highest daily gains per day, and which species will be able to extend your grazing season by covering the summer slump in the dead of the summer, and also extending into way beyond December, way beyond November. So using winter and summer multi-mixes, especially in sacrifice areas, so you can heal these areas, but also to provide some break to your cool season pastures, and graze them when they are mature. So this probably needs one presentation on its own, this finishing program, but into the fall, add your grass mixes and work your way into cold resistant winter forages like winter rye, wheat, barley, oats, ryegrass, and mostly grasses, because you need the energy. You should always avoid hungry cows, and always feed supplemental hay after, never before they graze. So think about a dairy pasture. A dairy pasture is a great example. Maintaining weight gains throughout the winter equals tender meat. So when your animals lose weight throughout the winter time, you produce a tougher meat. Other important points, have a sacrifice area, but keep your cattle out of the mud. Measure forage and animal performance and soils. Water must follow animals. Before a heavy rain, cows should leave a pasture if possible, and if they should walk on a wet soil, they should walk on the highest possible pasture you have to avoid destroying the soil. Another point, another tip about beef quality is direct cut unwilted silage preserves omega-3 fatty acids. I want to end up with this phrase, the sun provides the energy for plant growth, manure and urine provides soil fertility, cows recycle and transform plants into proteins, and the farmer must learn how to manage this. Thank you.
Great, thank you. I You know, I wrote down two things that I'm going to use from now on. I love the dining room, bedroom, bathroom, and the ghost bumps. I'm going to borrow both of those terms. So we have a lot of questions coming in, and we have about 15 minutes for questions, so that's great. So I'm going to just go in order of how they were brought in. The first one is about trampling. So, you know, we hear a lot of talk about trampling being desirable. But where is the line between how much we want to trample and when we just start to waste our forage inventory?
Oh, that's a great question. So trample is desirable. And I would ask like a provocative question, you know, why is trample desirable? When you trample, you are trampling forage that you haven't eaten. So there was, let me start this in a different way. Some think that, you know, trampling brings carbon into the soil, and trampling above the soil doesn't bring carbon into the soil. It breaks some of the residual pastures that were uneaten, and they will come back to the soil, but in a later time. What brings carbon into the soil is the exudates that plants release through their roots. And when you build the finishing program, if you have too much forage residual, you're probably not sizing your pastures well, or you're not sizing the amount of animals for your stock density. I'm not saying that never trample, but I'd say trampling can mean wasting forage, but depending on the objectives you have on your operation.
Got it. So the next question is, this was really pertinent last summer. A lot of people experienced extreme drought. And in this particular question, they said, you know, we had a severe lack of regrowth due to the drought, which then led to what we felt was overgrazing. Aside from increasing your land base, do you have suggestions for dealing with such a situation where you have these droughty conditions, regrowth is slow, increasing your rest period isn't working?
Yes, well, one can be, you know, have enough stored forage, you know, if you can. Okay, plan your grazing season a year or a year and a half before, and start building forage reserves for times when you have these drought periods. Okay, another more drastic way is to destock your pastures so that you can allow them to recover properly. But ideally, I like to see farmers with at least 1 year of reserves, of forage reserves, ahead, so that they have these extra dry feed or silage to give it to these to the animals when times like drought or other times arise.
Next question. So this is a question about dry lotting with the specific intention of saving pasture or resting pasture. So when you're using this dry lotting approach, what are the bale grazing do's and don'ts that we should all consider?
Well, do's and don'ts. I have less experience with bale grazing, so I will pass this question. I will probably, if there is a chance for me to respond to this question later, I will think through this question and respond later.
Yeah, we can pull the asker's name from Hoover and pass it on to you if you want to follow up. That's great.
Yeah, that'd be great.
Great. Okay, so here's a question that we're going to start to get into some numbers here. So does the high stocking density work for smaller farms? So for more detail, we graze 50 to 60 sheep plus 2 cows and a calf, and then we pasture meat birds following the ruminants. We have about 15 acres of grazing area. We have lots of forest, but we're just using the edges for shade and browsing. I've always wondered how small farmers stay ahead of spring growth while also maximizing the best time for grazing. We are also moving our herd every 18 to 36 hours.
Yes, high stock density always work, but you had to follow the grazing arithmetic to size your pastures according to the time of the year, because it will slow down towards the fall, so you need to plan that accordingly. In subsequent years, you will keep producing more and more forage, that will allow for higher stocking rate, so more animals in the farm. But this is a sort of a slow process that happens over time and will flatten out in probably, I'd say 5 or 6, maybe 7 years, when you will have other things you can do to improve the number of animals in your farm, like irrigating your pastures or adding more stored feed, in times, or adding summer annuals, winter annuals, like I mentioned before.
And then, okay, so let's see. Any tips on evaluating available dry matter for winter grazing when the density is super low? Also, how to balance overgrazing while getting the most out of pasture in the late fall, early winter?
So you can always use the grazing stick to gauge how much dry matter you have. Those are available through NRCS, and sometimes I have extra that I can pass on. And then what was the second part of the question? Sorry.
The second part of the question was, it's sort of the famous, how do you balance overgrazing while also trying to get the most out of your pasture in the late fall or early winter months?
Okay, that's a tricky thing to do, because if you practice overgrazing towards the fall, you're probably gonna compromise your spring growth. So I'd say, unless you have a reason to do it, either because you want to implement a new pasture there, a frost seed or something, I'd not overgraze under any circumstance.
So another question, this is one of the questions that I had during your presentation. The slide about increasing grazing efficiency decreases methane output. What was the mechanism behind that? What was actually going on that causes that biology to change?
I believe is the intake. The more intake in the least time decreases methane emissions. I believe that's what's behind that study.
Great, cool, thank you.
Yep.
So it looks like for the moment, our questions have stopped coming in. So if anybody on the Hoover side has any more questions, please do send them. I'll stall and buy them. Oh, great. Oh, here's a reminder, an important reminder that, if any participants come up with questions following this, especially with those numbers, the grazing math, definitely feel free to call Extension for help with grazing, including farm visits as well. So I'll ask you a selfish wild card question, since you mentioned the annuals. So, we've done a lot of work with grazing small overwintering grains, rye wheat and triticale. And one year on farm, we had triticale, a variety that we'd grown before and knew pretty well, pop up with an NDF of 65 when it was in the boot early heading stage. And we just couldn't find any justification, physiologically, environmentally for that. Have you ever seen something or that might solve our farm mystery of what caused that?
Was it overgrown?
Nope. It was no, not at all. It was great. I mean, they did add some nitrogen. Well, they just couldn't help themselves. They did add some nitrogen fertilizer in the spring, but other than that, it was planted after corn silage and pretty standard, good harvest time.
Huh. I wonder if specific to that variety of did you say triticale?
It was, yeah. And we had done some work with it at a few other farms and at our research farm. And it was this one, it was a 40-acre field.
Mm-hmm.
And it sort of felt like a bust a little bit.
Uh-huh.
And we never could quite figure out, what the heck happened.
Right. It could be a number of things. Thank you.
Yeah, great. Well, that's all of our questions for today. So Juan, thank you so much. We'll get you that question for Huva. And if anybody thinks of any questions after today, go ahead and keep submitting them in the Huva chat or the Huva Q&A box, and we can get them to Juan after today.
That'd be good. Thank you so much.
Thank you. Bye, everybody.